In this video, I'll talk about the rotational dynamics of a centrifuge. A centrifuge is simply a rotating device or is a spinning disk. The information that is given is the radius of the spinning disk or the centrifuge, which is 25 centimeter, and it rotates clockwise. So that means this direction. When this machine is turned off, it comes to a stop, and from its maximum rotation or 4000 rpm, that means 4000 revolution per minute, and it takes 30 seconds to come to a stop. Now you need to find out the average angular acceleration, the tangential acceleration, the net acceleration, the total acceleration. Okay, so here we might be using a lot of terminology, the same kind. For example, angular acceleration, the tangential acceleration, angular speed, the linear speed, the centripetal acceleration. So do not get confused. Okay, and I already have made another videos about all this terminology, so please watch those videos as well. So let's start now. The radius is 25 centimeter. The initial angular speed, omega I, stands for the angular speed, which is 4000 rpm, revolution per minute. What does this mean, revolution per minute? The 4000 revolution per minute means in 1 minute or in 60 seconds, this centrifuge machine turns 4000 times, or it makes 4000 complete turn in 1 minute. And we need to change whenever you're going to use the dynamics equations, then you make sure that your angular speed is in the unit of radian per second. So this is the unit you need to put in. So we have to change revolution per minute to radian per second. How do we do that? So here is the formula: rpm to radian. 1 rpm is the revolution per minute, and 1 revolution is 2 pi radian. That means if it makes 1 complete rotation or 1 complete revolution, then the total angle is 2 pi radian, and 1 minute is 60 seconds. So 2 over 60 is 30. So in order to now change from rpm to radian, you have to simply multiply over pi by 30. So here now I'm multiplying pi over 30, and it will take me to radian per second, which is 419 radian per second. And the final angular speed is 0, which makes sense because it has finally come to a stop, and the time to come to a stop is 30 seconds. So we're going to calculate the angular acceleration, and this is average angular acceleration. So how do you calculate the average angular acceleration? The way you calculate is change in the angular speed divided by the time. That's what it means, the change in the delta. This triangle is the delta omega divided by the delta time, which is the change in the time. The final angular speed is 0, and the initial angular speed is 419. And the total time is 30 seconds. If you do the math, what you get is negative 13.97. What does the negative sign means? I would like you to pause the video and think about what does the negative sign mean. The negative sign simply means this spinning disk is slowing down, or it is coming to a stop. That's what the negative sign means. So this is the average angular acceleration. Now let's calculate the tangential acceleration. In order to calculate the tangential acceleration, the tangential acceleration is simply r times alpha, and r is the radius. So if you simply multiply this angular acceleration by the radius, you'll get the tangential acceleration. And it is asking you to calculate at 20 centimeters I think this has to be 25 centimeter. So at 25 centimeter away from it, so this is what you get, 3.49. The one thing now you need to notice is the tangential acceleration is the distance dependent. It depends upon the position where you are at this point or this point or this point. The further you are, the more the tangential acceleration you have. But the angular acceleration, it doesn't matter where, this point, this point, this point, or this point, it is exactly the same. But the tangential acceleration is dependent on the position. The further away you are, the more the tangential acceleration you will have. Okay, so if you need to think about the differences between the tangential and angular acceleration, so the tangential acceleration is always at the tangent, okay, and the angular acceleration, the direction, depends upon whether it is a speeding up or it is slowing down. Now let's say there's a spinning disk here. This spinning disk is turning clockwise, so you have to use your right hand curl rule, and the right hand curl rule tells you, let me just show you 1 second. Let me bring out one thing here. So what does the right hand rule tells you is, if you curl your finger just like this, if you curl your finger in the direction of the rotation, then your thumb points out the direction of the angular speed. Okay, so that's the thing you need to keep in mind. So in this case, if I turn my fingers in the direction of the rotation, my thumb points downward, or in other words, it points downward this way. That's the direction of the angular speed. But my angular acceleration will be upward. Why is that? Why? How come my angular acceleration will be upward? And the reason is because the spinning disk is slowing down. If a thing is slowing down, or if a spinning disk or a fan or a turbine or a generator is slowing down, the angular speed and the angular acceleration will be in opposite direction. Okay, so the angular acceleration, remember, the angular acceleration can be either upward or downward, and the tangential acceleration is a tangent at the different points. Okay, so that's a short explanation about the different things, and watch my other videos to get a clear explanation about all this terminology. Okay, so now let's calculate the angular speed. The angular speed is omega time is equal to omega I plus alpha t, and this is the final angular speed, this is the initial angular speed, alpha is the angular acceleration, and t is the time. And we are asked to calculate angular speed at 29 seconds after the machine is turned off. So the time is 29 seconds, and we know that the initial angular speed is 419. The alpha we just have calculated is here, 13.97, and the time is 29. So if you plug in, what you get is 13.87. That's the angular speed. Now let's calculate the tangential speed. The tangential speed would be again r times omega. That's the formula for calculating the tangential speed. Or if you simply multiply this by r, that gives you the tangential speed. And the tangential r, the distance, is also given here. It says the 25 centimeter. So the 25 times 13.87, if you multiply, you'll get 3.47 meter per second. Just take a note here. So the angular speed has a unit of radian per second, and here it has a unit of meter per second. Remember, the angular speed, the direction, again, can be either upward or it can be downward. But the linear speed has either this at the tangent. Okay, so we now calculated the tangential speed. but our goal is to calculate the another acceleration, that is the centripetal acceleration. So when an object is moving in a circle, then it does have many acceleration. The one acceleration is the tangential acceleration, and this tangential acceleration comes only when it is not moving with a uniform speed. If it is slowing down, then it will have opposite to the velocity. This disk is spinning this way, but as it is slowing down, the tangential acceleration is opposite. But the centripetal acceleration is always towards the center. Okay, so the net acceleration will be at some other angle. All right. Okay, so the formula for calculating the centripetal acceleration is vt squared over r, and this is the tangential velocity, or you might have studied about a centripetal force, which is mv squared over r. So this is the acceleration, v squared over r. That's exactly what it is here. And the tangential acceleration we just calculated 3.47, and the radius is 0.25. That gives you 48.1. That's the centripetal acceleration. So the direction is appropriately shown here. This is the centripetal acceleration, and this is the tangential acceleration. So net acceleration is at some other angle. So how do we find out the magnitude of the net acceleration? It can be given by the square root of ac squared plus at squared. You can clearly see this is a right angle triangle. If I just look at this way, so this is the net acceleration, and it will be a square of this term, the square of this, which is the tangential acceleration, and then take the square root. That's how you find the hypotenuse. So ac squared plus at squared, ac is 48.1 and at is negative 3.49, and what you get is close to 48.2. So the net acceleration is still close to the centripetal acceleration. And the direction, the total acceleration is not radially inward, because it has a small component, the tangential component. The way we can find it out is the tangent theta is AC over AT. So if you have something just like theta here, then rise over run gives you the angle here. So in this case, if I look into this triangle here, the rise will be AC and the run will be AT, because I'm taking this angle, AC over AT, the tangent theta. And if you calculate, and you'll get 85.9 degree. Again, the negative sign simply means it is opposite to the motion here. Okay, so this gives you the direction, and that's it for the centrifuge net acceleration. So again, if you want to understand all the terminology, if you are not familiar, watch my other videos. And if you have any questions, any sort of questions, write down your questions in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you.